Hello and welcome to Geraldine the Daydreaming Giraffe. And there she is right there. She's a pretty little thing, but bummer for her. She's been trapped within this irregular prism. That is no good. Hey, this is a watch me problem, which means all you need to do is sit back, relax, and watch to see how this problem is solved. And then at the end, copy all the information into your notebook. Without further ado, let us move on to our scenario. Alan Clintock is an animal collector. Shame on you. He has trapped Geraldine the Daydreaming Giraffe. He wants to keep her in the irregular prism below, right here, my friends. You are her only hope of escape. Solve for the volume of her prism, and Alan Clintock will have to release Geraldine the Daydreaming Giraffe back to her animal reserve. Alrighty, so let's go ahead and get started. We've got a number of measurements here for the different edges, and we're going to just plug those in and figure out what the volume is here. Now, the first thing I like to do when you have an irregular prism here, you're really looking at the area for volume, not the area, the volume for an irregular prism is V, or volume, equals length times width times height, right? Now, if you think about this, you can also think about it as volume equals area times height, because length times width is really the area. And if I look at this top area here, if I solve for all of that, then I would have the area of this top portion, which is an irregular polygon. Remember, polygon is a two-dimensional figure, so I'm just looking at just the top portion. And then that would give me the area, and all I would have to do is multiply that by the height, and I would have my volume. Alrighty, so let's go ahead and get started by figuring out what each measurement is here. So if I've got this measurement for this edge here, and if I multiply it by the 12.5, I would have this entire box right here. And that's the first thing I'm going to do here. So I'm going to take 12.5 and multiply it by 7. Let's go ahead and do that right now. So I'm going to make this good and big. And we'll take our 12.5, 12.5. And we shall multiply that by the 7. Okay, 7 times 5 is going to give you 35. Drop your 5, carry your 3. 7 times 2 is 14, plus 3 is going to give you a 17. Drop your 7, carry your 1. And then 7 times 1 is going to give you a 7, plus this 1 here will give you 8. And you're not quite done because you got one loop-a-doop here. So one loop-a-doop here puts our decimal right there. And we end up with 87.5. And these are meters squared, but we're not going to worry about that right now. We'll wait till we get to the end. So for that first section there, we've got 87.5. Let me rewrite it again, nice and big, 87.5 for that section right there. Now, I need to figure out what this section is here, and then I would have the total top surface area, and let's go ahead and do that right now. So if this is 12.5, and from here to here is 9.5, that means I'm simply going to take 12.5 and subtract 9.5 from it. And 12.5 minus 9.5 is going to give me exactly 3. So let's go ahead and enlarge this. And I'm going to say that this section right here is 3 meters. Okay, and that's going from here to here. And once again, if I do it backwards, if I take 3 plus the 9.5 here, right? And if this is 9.5, we know that this is also 9.5. So 9.5 plus 3 would give me 12.5. And that's exactly from here all the way through to there, right? Perfect. All right. So now I need to figure out what this section here is. And if I know that the whole distance from here all the way to here is 9.5, and from here to here is 7, that means, once again, this is going to be a 7, and from right there to there is 7. So I can take this whole distance, 9.5, minus this 7 here would give me this area here, right? Well, yes, right. And that means that this section right here is going to be 2.5. So I'm going to write that right up there because if this here is 2.5 from there to there, that means from there to there is also 2.5. So let's go ahead and do that. We'll make this 2.5, and that is meters, right? And now all I have to do is multiply 2.5 times the 3 here. And let's just do it right here. We're going to take 3 times 5 is going to give you 15. And I'm going to drop that 5. I'm going to do this in red. Drop the 5. And I'm going to hold the 1 in my brain. And then 3 times 2 is going to give me 6. Plus the 1 from my brain is going to give me 7. So I've got 7 here. But lo and behold, I've got 1 loopy-doop here, which means I got to go 1 loopy-doop here. My decimal is going to go right there. And I'm going to end up with, right here, 7.5. So that's going to give me the surface area for this little section here, right? So now I've got this big section here is 87.5, and this little section here is 7.5. So now I need to add those two together, and I will get right over here, that will give me my area for the top portion here, right? So let's go ahead and do that right now. I'm going to do that over here, actually. And I'm going to take the 87.5, and I'm going to add in the 7.5. And 5 and 5 is going to give me 10. Drop my 0, carry my 1, drop my decimal. And then 7 and 7 is 14, plus this 1 is going to give me 15. Drop the 5, carry the 1, and 8 plus 1 is going to give you 9. And whoops, that's a sloppy 9, isn't it? Let's make that a little better. 9. Bingo. There we go. And you're going to end up with 95.0 or really just 95. So let's come on over here and we'll plug this in. I'm going to do this in blue now. V equals, and it is 95. And I'm multiplying that by the height, which over here is 13. As you see right here, from here to here is 13. So I'm going to multiply by 13 over here. Let's drop the 13 right there. And just to recap, all right, the volume is length times width times height. And length times width is really what you solve for the area, right? So I decided to create this whole top section as my area and solve for that area of this top section, which gave me 95. And now I'm multiplying it by the height, and that will give me the volume. So let's go ahead and do that right now. And here we go. We'll do our math right here in the middle of this face right here. So we've got 95 times 13. And let's start with 3 times 5, which is going to give us 15. I'm going to drop the 5, carry the 1 right there. 9 times 3 is going to give me 27, plus this is going to give me 28. I'm going to drop the 8 and the 2. Then I'm going to drop a 0, put an X in it, because this 1 is really a 10, not a 1, right? So it's in the tens place. So we got to hold that place value. So now let's start with 1 times 5. Ooh, very tricky. That's going to give us 5. And then 1 times 9 will give us 9. And we are ready to simply add these two bad boys together. And we get 5 and 0 is going to give us 5. 8 and 5 is going to give us 13. So I'm going to drop the 3 and carry the 1 right there. And then this 1 plus 9 is going to give me 10. Plus the 2 is going to give me 12. We've got the 2 and the 1. And we got to drop our comma. And this is going to be meters. And it's cubed because, remember, we've got 3 dimensions, right? So we've got our length, our width, and our height. So that means it's cubed. So let's go ahead and just plug in our answer. And this is the best part because we're all done now. V equals 1,235 meters cubed. And that, my friends, is the volume of Geraldine the Daydreaming Giraffe's trap that is a irregular prism, and it is her trap that she's trapped within. And hey, we have just released her because we solved for the volume correctly, and that is wonderful. So now Alan Clintock has to release her back to the animal reserve, and that is lovely for Geraldine, my friends. So what I'd like you to do right now is go ahead and pause the video. Make sure you have all this information copied into your notebook, and then you're ready for the further problems that we will do involving volume. Until next time, I hope you have a fantastic day. I'll see you soon.